Okay, we'll start off with a quiz. So if you're a distant student or if you're in the class and you aren't here today, here's a quiz. You should stop and work it before we go into it. Okay. Well, hopefully everybody thinks on getting this on video. Stop and get it. I think really, if you're just a student or if you're not here, you gotta look at things and send it to me before you see what I do. Okay. Then you can make a few notes about what you saw and what you missed, and you'll learn something. Okay, you learn something important. Please consider doing that. It's actually required. Not seeing a lot of response to a lot of these things. We'll talk about that. On the other hand, everybody here seems to be doing pretty much okay. Okay, so what's F of A? Well, I've got A here. I've got X here. That means I'm replacing X by A. So F of A would be the square root of A. Now what have I got in the parentheses? I've got F of X plus H, which is like F of X, except I've got X plus H here. That means I've got to replace X by X plus H, and I replace it here by X plus H as well. And there it is. Now that's a straightforward process. You've got to get in your head that you replace X. Okay. And you got to get used to reading this. So if you did the assignment and didn't pick up on that, think about what you need to do. Everybody's different. How do you need to approach? First place, remember that you need to be writing out your assignments and bring them in your notebook to class. Okay. So I can see what you're doing, so I can see if there's something I can tell you, it'll help you get it together. Because most of the class didn't do particularly well with this. Some people did. People got both of these. And I give full credit in the quiz for these. Now you should theoretically be able to do this as well. If you've successfully done the assignment and understand the pattern. But this is something that I expect to kind of throw a little twist in it. So I would give full credit just for getting these. Okay. Most people didn't get full credit. Okay. If you get these, I'd probably give you an extra point. And these things mount up, it can make a difference. Okay, what's G of F of X? Well, I'm going to need a little more room than I gave myself here. I've got G. So I got to look at the definition of G. G of X equals X plus 4. Now what's X been replaced by? It's been replaced by the symbol F of X. Okay. So if I replace X by F of X in this definition, what do I get? Well, write it down for me. Don't have your notebook, you grab a sheet of scrap paper. But write down what do you get if you replace X by F of X? Okay, now most of you have some, so you're still thinking about it, so that's okay. But I'm gonna have to keep moving here. Okay. Next one, if you're a distant student, do what I just said, right? Or if you're missing class and you're catching up in the video, you'd be able to do this. So again, I got the definition of G of whatever's in parentheses here, right? Whatever's in parentheses here is going to be your X, and this is going to be whatever was in parentheses. So whatever's in parentheses goes here, and everywhere else you see X. So what's in parentheses? F of X. Yes. F of X plus 4. There's the pattern. G of X is X plus 4. So G of F of X is f of x plus 4. Now, what's f of x? We have an expression for f of x here. So when we see f of x, we could write square root of x, couldn't we? To do that. Okay, now what we're doing is this. Somebody seemed to be doing f of g of x or something like that. We've got f of x plus 4 here. And f of x is the square root of x. So we can simply write this as square root of x plus 4. And most people pretty much got that. Some people got it perfectly. Some people extended that square root sign to include the 4 with the square root. If f of x is a square root of x, and that square root doesn't get to extend to everything else, right? So you want to be careful about that. Okay. Now, what would you do then with f of g of x? Using the definition of f of x, what are you going to get? Now, there are two steps. You use the definition of f of x, then use the definition of g of x. You do it in the opposite direction too, but we're going to do it just one way right now. Okay, now people having a good bit of trouble with this. So I'm going to do f of g of x. I want to do it a certain way. First of all, can you write out the definition of f of x? Well, write it out. Start somewhere down below whatever you've worked on, write the definition of f of x. Definition of f of x is f of x equals square root of x, right? So I'll say write down the definition of f of x. There's where it's defined. If we write the definition of g of x, there's where it's defined, right? So we write definition of f of x, which is all I asked you to do right now. Okay. Now, put an equal sign here. And instead of f of x, we're going to write the thing that we're trying to do, f of g of x. Okay. Now, what have we done? We've replaced x by g of x, haven't we? So right below this, write this expression, replace x with g of x. Okay, so if we do that, people seem to have gotten that correct, you're going to get the square root of g of x. Now, of course, we've got an expression for g of x, haven't we? So we're going to write equals this, but we're going to replace g of x by what g of x is equal to. So what do you get? Write it out. Okay, now the definition of g of x is g of x equals x plus 4. So wherever we see g of x, we can always write x plus 4. When we see g of x here, and now it's perfectly, I mean, it's implicit that this equals this equals this. Let's just write it out really explicitly now. G of x equals the square root of x plus 4. Okay. I'm going to picture this just a little bit more. That make a slightly more involved picture. Okay. So we want to find what is g of f of x equal? Well, first, we go to the definition of f of x. So I'm going to write this out. I'm going to use colors a little bit so we can make it. So of x equals square root of x. Then wait a minute, I'm sorry, I'm at backwards, son. I was bored, I lost track of which composite I was doing. Okay, let's try this, do it right, okay. Now, g of x. With this thing. All right, I think I'm okay. Okay, so we're trying to do f of g of x and equals 1. And so I'm going to take my two definitions. First definition is f of x equals square root of x. Okay. Now my expression here is f of, and I'm going to use a different color for g of x. Now, what is f of g of x equal? Well, here we have x, and here we have g of x. What we're going to do is this x is also going to be g of x. So, and I get square root of g of x. X has been replaced by g of x. So this x replaces g of x. So we've got g of x. Then g of x is x plus 4. Right there's our definition of g of x. So replace g of x plus 4. That equals f of g of x. Now the colors might or might not help. If they don't help, ignore them, just write it down the way it is. But you understand the x is being replaced by g of x. So this x is going to be replaced by g of x. So draw the arrow on this way, and then that comes down here. And I'm not sure all those arrows make sense to everybody. They make pretty good sense to me, but I'm more used to looking at diagrams than you are. So if they're not helpful, ignore them and go back to what we did here. But try to clarify this to yourself as best you can. Okay. Okay, well, that's the idea of composite functions. You're going to encounter that in your course. Now, if you're in the distance course, you're going to encounter that pretty soon. I think next week. In my course, that'll be a couple of weeks. So you want to store it away. You want to think about this and want to try to make sure that you understand this whole process of substitution to get the composite. There's much more to it than that. If you understand this, this is always a hang up for people. That's why we're covering it here before we cover it in class. And I'm giving those who are in the distance class a heads up that this is coming up. You're going to see it real soon. Okay? And F of G of X then is square root of X plus 4. This is your basis. Okay, now I want to talk now about domain and range. As those terms apply to graphs. We talked about it last time. We talked about like if you have this square root of X plus 5, well, X has to be greater than or equal to -5, or you're going to get a negative. We talked about how to do that. Then of course you have an assignment to do tomorrow. Okay. Now let me just digress a minute. Remember, if you read your assignments page, and you need to read the assignments page every day. You have the information you need to register for the half credit course, for the half credit site. So if you're behind on these assignments, go to the half credit site and do them. There's an amnesty I said was due through the end of this week. I'm going to extend it to Monday, or I'll transfer your work at that site for full credit. And this normally I transfer for half credit, provided that improves your score. Okay. Not going to do anything that lowers the score you've already made. But you got to be reading the assignments page. Nobody anywhere has registered for the half credit page, and that message has been on the assignments page for 3 days now. Okay, I'm not talking about just to go on, talk about all my classes. Okay, so I'm getting the idea that people maybe don't know they need to be reading the assignments page. That's where the videos are. That's where everything is. So make sure you understand that. And of course, if you're viewing this video and don't know where the assignments page is, it's a little bit of a conundrum because videos are on the assignments page, so you can't be viewing it. Okay, a little contradiction there. Probably sent out another email. I don't like to send out too many emails. All the information is there on the assignments page. If I send out emails and put on the assignments page, people end up not knowing where to look, and they see the information twice, and it's confusing. Okay, it's very simple. You do what's on Canvas. You go to the assignments page. You email me saying you've done that. Very few people have done that, and several have. Okay, so I know that you're looking at the assignments page. Okay, well, make sure you're doing that. Okay, now just let's go over to this now. Okay, so let's say we have a graph. Here's the y-axis. Here's the x-axis. Let's say the graph looks like this. Of course, I'm a little parallel. But yeah, there my y-axis needs to go a little higher. Okay, and let's be sure we understand that at this end, we include the point right here at the end of the curve. And at this end, we're going to not include the point. Okay, so solid dot means we're including that point. An open dot means we include every point up to this end, but we are including the point right at the end. All right. Now remember, your domain is all of your x values. So if you have the square root of x minus 5 or x plus 5, x plus 5 would have to be greater than 0, greater than or equal to 0. I just solve that inequality, find that x has to be greater or equal to -5. Of course, you can just figure that out. X plus 5 is such a simple term, if you remember what we did. Okay. Okay, so set of all the x values here. Well, we can do this. We can take this point. Of course, this actual point is not included, but every point up to it will be. And we can take this point. Okay, so there is a value of x that goes along with this point, right? Now, there's no value of x that goes along with this point, but we still want to mark that point because every value up to this one is going to have a graph point. So if we look at the x values of all the points, and I can't draw them all, but I drew a bunch of them, okay? We can pretty clearly see for all the x values that give us points in this graph, plot. Now that's a pretty simple picture, isn't it? Okay. And then we can shade this interval of the x-axis. In this interval is our domain. Now, if this function is the curve represents y equals f of x, then this is the domain. Of f of x. Okay. It's just a name, but we used that name a couple days ago. Okay. So that's pretty simple, right? So I'm going to draw another one. Make a copy of something that looks kind of like that. And then show me where the domain is. Just do what I did. You don't have the colored ink or colored pencils. So you don't have to do it in color, but go ahead and make that sketch. Then I'll make it and see how you did. Okay, now, I think it's still working. We need to move on. Most people have this pretty well done. Okay, so I said, whatever I did up here, do it down here. So what I do up here, well, first thing is I put a dotted line from this end point down, from this end point down. So. There it is. So next thing I did, well, I think of putting a dotted line from every point up here down. Now there are infinite number of points. Okay. So I can't do them all, so I do some of them to indicate that these are the x values that go with these points. Now I've got an open circle around this point. So I'll put an open circle around here. And this is an open circle, so I'll do an open circle here. This interval is domain. Now, if I call this function g of f, then I can actually complete everything I did up here. This is a domain of g of x. Okay. Now, I'm going to do the range. The range I didn't talk about this last time. Range is just the Y values. All I do is I draw lines straight over. And I'm going to start with the highest point, go down to the lowest. And I'll do all the points in between. This point here, go here. Here, one here. Now I got a couple more points over here, so I'm gonna do one here and one that goes over here. And one that goes over here. Now, that's one little tricky thing about it. Should be clear what I did. I draw lines right in every possible horizontal line I can through points of this graph. Every horizontal line I can reasonably do. You don't want to do 100 of them. Probably ought to do 10 because this took long to make them. Get a better picture. Okay, now, this point up here, is it included? Well, it's got a closed dot on it, so it is. What about this point down here? Is it included? Oh, yeah. There's no circle around the point that this one came from. This is the lowest point. It's going to be included. Now, kind of a tricky question. Is this going to be included? This point that we got from the point where the open circle is. Well, the answer is yes, it's included because it's the same point that we get from this point on the graph, which is included, right? This point's included, so this point has to be included. So all these points are included, even though this last point here isn't. And now here's the range. Okay. Now, can you show me the range of geovex? Can you do everything I just did with that geovex? Okay, well, I'll have to do this, the geovex function. I'm going to do horizontal line here, here. And all these, remember these lines are horizontal. They don't go up, down. They don't squiggle around. They go straight over to the y-axis, right? Because we want to get the y coordinates of these points. And then this point won't be included. This point won't be included. Every point in between will be included. So this is the range of geovex. Now there's some algebra that goes along with calculating the range, just like there's some algebra that goes along with calculating the domain. The algebra there is a little more complicated, and I'm not going to talk about it right now. Okay, we'll talk about it maybe a little bit next week. As the distance class, at least, it's the point where they actually, distance class is at the point where they need to be able to calculate this. This part is due tomorrow, but right there it is with the pictures. And I'm just not going to have time in this class because of the schedule glitches that have occurred because of weather. So we have to move on to other things. I would like to go ahead and do the algebra that's involved with calculating the range, but I have to kind of leave that one right now. Okay. Okay, what we've talked about so far is about the shapes of functions. That's real important. Okay, what we're going to talk about, and then we've talked about some techniques we use to learn things about motion. And the camera's out of focus, you gotta focus it on something. Doesn't seem to want to focus on me, but it likes the lighthouse. Okay. Well. In focus. Okay, not you, yeah. Yeah, there it is. All right. Hopefully it'll stay focused. Can anybody tell me what kind of a function I appear to be graphing here? Okay. Nobody seemed to want to ask. That's kind of what an exponential function looks like. And of course, we learned in my class how to construct a graph of this. And in the distance class, you had the assignment. You also had it in this class on your toolkit functions. So that's kind of a picture of your toolkit exponential function. Okay. Just mentioning that because you really should recognize this. And the time will come when you actually do. And I don't know what I did with all the chalk. At least I'm consistent about where I lose it. Okay. Now, I take 2 points on this graph. Then I can find the x coordinate of each one. And by x coordinates. And here are my y coordinates. Here. If I move from the point on the left to the point on the right, then my x coordinates change right here. A little arrow for the change in the x coordinates. And you know, the camera just took it into its feeble little brain to zoom back to Boone, North Carolina. So you can't read the board. And even I look tiny. Well, not really. But it just decided, just didn't want to be focused the way I wanted it to focus. Didn't want to be zoomed the way I wanted it to zoom. It decided to be zoomed as far away as it can get. And this is very irritating, especially when I go on for a while and people can't read the screen. Also shows that it's kind of messy up here. So I have to expect that. I have to acknowledge that. Okay, so I don't know when the camera decided to make the screen really tiny or make the picture really tiny so you couldn't see anything. But let me again explain all I've done. I just marked 2 points in this graph. I marked the x coordinates, 2 vertical lines, so I can see where the x coordinates are. And then I drew horizontal lines so I could see where the y coordinates are. Then I drew an arrow from left to right for the x coordinates. Okay. Then I drew an arrow from the leftmost point to the left, from the y coordinate of the point on the left to the y coordinate of the point on the right. Okay. In other words, this arrow represents the change in Y. So what I have is an arrow here. It's the change in X. And we call that delta X. And this, of course, is change in Y. And we call that delta Y. It's represented by that arrow. Okay, well now, I can draw these arrows again. I don't have to draw them with the axis. I can draw the arrow here. And this is also the change in X. So we have the change in X represented both here and here. And we have the change in Y represented here, and we can also represent it here. So there's the change in Y, and also over here, we have the change in Y. Make sense? Now, since the X and Y axis are at right angles, these arrows make a right angle. And that's important. And I can draw a straight line between the points. And except at those points, since this curve is concave upward, and that's a terminology you'll pick up through open math. Concave upward is like this. Concave downward is like this. So a parabola that opens upward, ones we've learned to construct for the toolkit squaring function. Okay, is concave up. If we turn that over, it's concave down. Okay, well, we've completed triangle. This is the hypotenuse of this triangle. Now I want to draw this triangle a little bigger. Put a circle around here, and then arrow down here to make a bigger circle. It contains the same triangle. And we have our change in X, which I can call delta X. And we have our change in Y. I can call delta Y. And we have the 2 points on the graph. Then, say I use green chalk up here for the hypotenuse of the triangle. That's supposed to be a straight line, but I screwed it up. But that's a straight line. Just accept it as a straight line. Okay. A weak straight line. Okay. So there we have it. Okay. Now, we're going to call delta Y the rise because it goes up. Now, what do we call something that goes over? We don't have a universal word for that. I'm going to call this the run. Delta X is the run. Delta Y is the rise. Then we have payoff here. Not really red as pink, but I can't bring myself to call it pink. Now, let me just ask, have you seen the word slope used in your prerequisite courses? Okay, now, the first answer I got when I asked the question is, well, y equals mx plus b. And that's totally relevant, because that's the equation of a straight line with slope m that intersects the y-axis at b. So if we find out where this thing intersects the y, it looks like it intersects just a little below the origin. Okay. That y-coordinate would be b, and the slope would be m, and we have an equation for this line. And that's important and relevant. It's coming up. Something you actually should already know about if you've had the prerequisite course. By this people taken the prerequisite courses, but haven't really had them. So that's what they know. That's a use of the slope. How about the definition of a slope? How would you calculate the slope if you knew the rise and the run? Okay, nobody seems to answer. Everybody's kind of looking at their feet. Don't worry about it. I mean, make sure a little bit. Make sure you get it down. Then don't worry about it. A slope is rise divided by run. Which is the change in y divided by the change in x. Now the slope is perhaps the most important concept in mathematics. No, there are the arguments for other concepts. Because the slope leads to the concept of the derivative. The slope is the rate of change, and the derivative is generally used as a foundation for calculus. Calculus is immensely powerful. You can't start calculus without the slope, or alternatively without the interpretation of area. Now that's down the road. I just want you to understand that this is really, really important. Okay. This is we're preparing, we're supporting a pre-calculus course. Pre-calculus is the course that is a prelude to the course where this is the first major concept, along with maybe the concept of the limit that you see. Okay. And you use it throughout the first semester of most calculus courses. And then you build on that, do what's called integrals in the second semester. Okay. The slope is foundation of the idea of the derivative or the rate of change. Okay. Let's just say now that we wanted to calculate the slope. Let's say that this is x equals 5. This line is x equals 10. And this line, which I'll extend way over here, along with this one, is y equals 40, y equals 25. So what's the rise? How would you calculate the rise? Okay, now most people got this and some people is processing it, but it should be obvious. Rise is the change in y. So we better have the two y coordinates, right? So we calculate the rise. using the watch coordinates, which are 25 and 40. Does everybody want to tell me what we do with those two numbers? Well, if you think about it, it should be pretty obvious that this arrow goes from 25 to 40. How far is that? 40 minus 25, right? Okay. Now, whether you do the calculation in your head or not, if you count by fives, it's fairly easy. It's okay. You do need to understand that you're going to subtract where you start from where you end. Where this arrow starts is at 25, where it ends is at 40. So that's your rise. Calculate the run. And pretty clear that if you start at 5 and end up at 10, you went 5 units in a positive direction, right? Okay. Now the slope. Rewriting. I've already written. That's what I think. There it is. There's your slope. Okay. Now I'm going to put another word instead of slope. It's the average slope. So effectively, I've defined average slope. I just used the word slope here because I didn't want to confuse you with the word average in case you remember something about slope. Okay. But officially, it's an average slope. Now, what's happening to the slope of this graph? If I calculated the slope at a later point, would it be more or less? Well, you can think if I calculate even starting from this point and go an equal distance for the run, I'm going to have to go up further because the graph is getting steeper, right? So I'd say the slope is increasing. That's an important characteristic of a graph. Okay. The slope is increasing, then you say the graph is increasing. If the slope is increasing faster and faster, you say it's increasing at an increasing rate. I say it. And then it's concave on. Okay. Now there's other ways to phrase that and other ways to understand it and look at it. Now, in general, we have this definition. It's a fairly obvious idea. As long as you don't try to apply it to tricky situations get done by tricky. Okay. If you make $100 in 20 hours, at what rate are you making money? Okay, if you make $100 in 5 hours, the rate at which you're making money, well, you divide the number of dollars by the number of hours. $100 divided by 20 hours gives you $5 an hour. Not great money, but if you don't have anything better to do with 5 hours, $100 is worth looking for. Okay. Okay, so that's the rate of change of your money with respect to time. This is your money, that is your time. Your money is going up at a rate of $5 every hour. Actually, 20 hours is a long time to work at a low wage. $100 in 5 hours, that'd be $20 an hour. That's not bad. Okay, so it's changing your money over the change in time. Abbreviate rate of change by ROC. And with respect to by WRT. Rate of change of Y with respect to X is change in Y divided by change in X. That's equal delta Y is your change in Y, delta X is your change in X. And I should have the word average in here. It's the average slope of the graph of Y versus X between two graph points. Okay, well, we're out of time, so I'm not going to write out between two graph points. But that's your connection between the idea of rate of change and a graph and a slope. So you really want to understand that. And of course, there's an assignment on it that builds on the ideas that we've talked about here.